You're parked in an empty lot at 2 a.m. Outside, the thermometer is stuck at 30 degrees below zero. The wind shakes the truck's body panels as if they were made of cardboard. You shut off the engine, and now you have to survive the next 8 hours inside this metal cabin without freezing. This isn't a scene from a survival movie. It's an ordinary Wednesday in the life of a professional truck driver in northern Canada, rural Russia, or the frozen plains of Montana. Week after week, for months at a time. What's fascinating is that these drivers wake up at dawn, rested, warm, and ready to hit the road again. How is that possible? What keeps a truck cab from turning into a giant freezer with a human being trapped inside? The answer is an entire system, and every part of it may surprise you. Before we explore the solutions, it's important to understand the true scale of the problem. A truck cab may look solid from the outside, but thermally, it's an enormous challenge. The walls are far thinner than those of a typical house. The windshield and side windows cover a large surface area, and glass transfers heat much more aggressively than brick, concrete, or wood. Even tiny gaps in the door seals act as continuous pathways for freezing air to enter. The floor presents another problem. Because it's connected to the truck's metal chassis, which is directly exposed to the outside temperature, heat is constantly drawn away through the bottom of the cab. Without any active heat source, a parked truck cab in temperatures of -30 degrees Celsius can reach life-threatening conditions in as little as 4 to 6 hours. There's also another challenge that most people never think about: the driver's own breathing. The moisture released with every breath condenses on the windows and eventually freezes on the inside. By morning, a driver can wake up inside what is essentially an ice-covered capsule with almost zero visibility. Before modern technology, this was a common and dangerous reality. Truck manufacturers have spent decades solving these problems through deliberate engineering. Modern long-haul trucks are built with thermal insulation inside the walls, roof, and floor. Their windows often feature double-pane construction with insulating air gaps. Door seals use multiple layers of weather stripping to create a much tighter barrier against cold air. The sleeper berth, the area where the driver sleeps, is usually positioned at the very rear of the cab, farthest from the doors and windshield. That's because this section loses heat more slowly than the front of the vehicle. This isn't a design choice for comfort or appearance. It's applied physics. The most immediate heat source available in a truck is the diesel engine itself. While running, the engine produces a tremendous amount of heat. That heat is transferred into the cabin through the engine's coolant system, much like the heater in a passenger car, but on a much larger and more powerful scale. Within minutes, an ice-cold cab can be transformed into a livable environment. The problem is operating cost. A diesel engine idling consumes between 2 and 4 liters of fuel per hour. 8 hours of sleep can cost as much as 32 liters of fuel. When multiplied across weeks of winter and years of a driver's career, the total expense becomes enormous, and trucking companies calculate those costs with remarkable precision. Beyond the financial burden, there is also a legal obstacle. In many US states and Canadian provinces, leaving a vehicle idling for more than 3 to 5 minutes is a violation of local regulations, with fines ranging from $200 to $2,000 depending on the jurisdiction. Authorities actively enforce these rules. The fines are real, documented, and far from uncommon. This combination of cost and legal restrictions forced the transportation industry to look for alternatives, and alternatives emerged. The first large-scale solution was the APU, or Auxiliary Power Unit. An APU is a compact diesel engine completely independent of the truck's main engine, mounted directly onto the vehicle's chassis. It doesn't move the truck. Its sole purpose is to generate heat, electricity, and during hot weather, power the air conditioning system, all while the main engine remains shut down and quiet. An APU typically consumes around 1 liter of fuel per hour. Compared to the 4 liters per hour often consumed by the main engine, the savings are substantial. In many cases, the investment pays for itself after just 1 or 2 winters. Many North American trucking companies no longer view an APU as an expense, but as an asset. It reduces wear on the primary engine, lowers emissions, and significantly cuts annual fuel costs. The downside is mechanical complexity. An APU is another machine with additional components additional maintenance requirements, and therefore another potential point of failure. And auxiliary engines have a curious tendency to break down under the worst possible conditions, when temperatures are at their lowest and demand is at its highest. Every experienced truck driver has a story about it. In the trucking world, that experience has almost become a rite of passage. The night the APU stopped working, and improvisation became the only option. But there is another solution, one that requires no auxiliary engine, no additional mechanical complexity, and consumes an almost negligible amount of fuel. Europe adopted it before the rest of the world. And once you discover why, you'll understand why Swedish and Norwegian trucks arrive better prepared for winter than almost anyone else. If there is one solution that combines efficiency, simplicity, and cost-effectiveness into a single piece of equipment, it's the diesel-powered parking heater. In Scandinavia, Norway, Sweden, and Finland, this system comes factory-installed in trucks from companies such as Volvo and Scania. It's not optional. It's not a premium accessory. It's standard equipment because the market demands it, and the climate leaves no room for compromise. The unit is roughly the size of a shoebox and is mounted beneath the cab. It draws a small amount of diesel fuel directly from the truck's main tank, burns it inside a controlled combustion chamber, and distributes heat either into the cab itself or through the engine's coolant circuit, warming both the living space and the mechanical components before startup. Fuel consumption typically ranges from 0.2 to 0.5 liters per hour. For a direct comparison, while the main engine might consume around 4 liters during the same hour, the parking heater uses only about 1/10 of that amount. 8 hours of sleep can cost less than 4 liters of fuel. The system is quiet, produces no exhaust inside the cab, and eliminates the need for an auxiliary engine along with all the mechanical complexity that comes with it. Companies such as Webasto and Eberspacher dominate this market globally, supplying fleets across all 5 inhabited continents. The technology itself is largely a solved problem. But there is one factor that no piece of equipment can replace, and it is what separates the driver who sleeps peacefully through the night from the one who wakes up in panic. The habits developed over years on the road matter more than any gadget, and they are simpler than most people imagine. A professional with real experience in severe winter conditions does not climb into the sleeper berth with a thin hotel blanket and hope the technology doesn't fail. They prepare for the worst-case scenario, even if they never have to face it. Their sleeping bag is rated for temperatures of -20 or even -30 degrees, not for 0, not for -5, but for true extreme cold. Their base layers are high-performance thermal garments. Their socks are thick wool, and in many cases, they even sleep wearing a warm hat. Another habit that makes a measurable difference is intentional preheating before stopping for the night. Before shutting down the engine, experienced drivers keep the main heating system running long enough to raise the cab temperature well above the comfort zone. When the parking heater takes over, it starts from a favorable position, which means lower fuel consumption and less strain throughout the night. There is also one safety check that sounds obvious, yet new drivers frequently overlook it: checking the fuel level before going to sleep. The parking heater draws fuel from the same tank that supplies the truck's main engine. Running out of diesel at -30 degrees in an isolated stretch of highway hundreds of kilometers from the nearest fuel station is not merely uncomfortable. It is a genuine emergency one that has already cost lives. Veteran drivers check their fuel level with the same seriousness that they check their own breathing. At that point, it becomes second nature. Now, we come to 2 risks that are rarely discussed when people talk about this subject, yet both can be deadly in ways most people don't immediately associate with cold weather. If you've made it this far, it's worth staying for 1 more minute. The first is progressive hypothermia. If the heating system fails, whether because of a mechanical malfunction, lack of fuel, or any other reason, and the driver does not have adequate personal cold weather gear, the temperature inside the cab can drop to lethal levels within just a few hours. The margin for error in extreme cold is far smaller than most people realize. The human body begins losing motor and cognitive function long before hypothermia is deceptive. People can simply fall asleep without realizing that their body is slowly shutting down. The second danger is carbon monoxide. Drivers who keep their engines running for warmth in areas with poor ventilation or where the exhaust outlet becomes blocked by accumulated snow, risk carbon monoxide poisoning while they sleep. The gas has no smell, it has no color. It gives no warning. It affects the central nervous system gradually and silently. Many experienced drivers carry carbon monoxide detectors inside their cabs as standard equipment, right alongside a fire extinguisher and a first aid kit. There is also a technical detail that few people mention, one capable of disabling the entire heating system on one of the coldest nights of the year. Conventional diesel fuel begins to gel at temperatures around -15 degrees Celsius, 5 degrees Fahrenheit. At that point, the fuel loses its ability to flow properly through fuel lines and filters. When this happens to the fuel supplying a parking heater, the system can simply stop working at the exact moment it is needed most. The solution is winter-grade diesel fuel, specially formulated to remain fluid at much lower temperatures and commonly available in colder regions, or the use of anti-gel additives added to the fuel tank before severe cold weather arrives. It's a simple adjustment that takes only a few minutes, yet it can determine whether the night passes uneventfully or turns into a serious emergency. So, how do truck drivers survive nights at -30 or even -40 degrees? The answer cannot be summed up in a single sentence. It is the combination of intelligently designed cabs with advanced thermal insulation, heating systems that consume only a fraction of the fuel once required, routines developed through years of experience, and personal equipment carefully selected for the worst-case scenario. It is a system. Every part depends on the others. Remove one piece, and the entire system becomes vulnerable. And as with almost everything in the world of transportation, when you take a closer look, you realize there is far more engineering, knowledge, and preparation behind it than anyone would ever imagine while watching a truck drive by on the highway. Thank you for watching.